Okay, welcome to my CCENT CCNA ICND1. This exam is based off, or this chapter is based off of the Odom 2013 Cisco CCENT CCNA ICND1 100-101 exam. In this section, we're looking at Chapter 15, Operating a Cisco Router. So, main points of this chapter are installing a Cisco router, looking at the Cisco Router's IOS, the CLI, upgrading the Cisco IOS software, and understanding its boot process. So to install a Cisco router, normally it sits at the edge of a network, though it could connect to multiple different networks, so it kind of just depends on your environment. Let's assume we have some type of two network setup, and so we might have a CSU, DSU, carrier sensing unit, data sensing unit in between our two routers. Network connectivity, ISP. That's essentially what we're talking about. That way we can connect two different networks. What does it look like? A Cisco 1841 looks exactly like this, except these two components right here, these HWIC cards, have the ability to be modular. They're not fixed, meaning you can replace them with any card you need. Here we have a fast Ethernet 1, fast Ethernet 0, a console, and an auxiliary port. These are fast Ethernet. On the 1941s, they're gigabit. We have a power switch. It's pretty self-explanatory. So, devices in a small home office network with some type of high-speed CATV could be a cable modem. Then from the cable modem to our router, and then all of our different devices that are connected. And then our cable modem may use like some type of broadband to connect back to the ISP for us to get internet. Again, that's very common. Most of the time, once we get past going that way, the cable modem, everything will be our Ethernet cable. Again, the SOHO router could be multiple devices. It could be a wired connection. It could be wireless. It could be doing VoIP. So the SOHO routers are normally classed by themselves because they're multifunctional. It could also have a built-in switch. So the Cisco router's CLI, very similar to a switch CLI. Normally, though, a router does specific items because they're going to be working on layer 3, meaning we're going to have routed interfaces, and they're routed based off of IP. If we have a serial connection, we'll have things like a clock rate. On routers, we have auxiliary ports. So a very generic router could be some basic interfaces, but we have to understand how we view those interfaces. Three of the big commands that you should know is show IP interface brief. That will give you a general overview of the interfaces, what they are, if they're addresses, if they're administratively down or protocol down. Show protocol and the interface will show if it's up. That's going to be both physically plugged in and turned on. Show interface will just give you a detailed breakdown of a specific interface. I have found that show IP interface brief is a very common one and very good to know. So interface status codes, normally the line status, which is the first status code, refers to layer 1 status physically. The protocol status, the second code, refers generally to the layer 2 status. It is always down if the line status is down. If the line status is up, but the protocol status is down, this is usually caused by a mismatch in data link layer configuration or the incorrect cable. So the line and the protocol status, administratively down, comma down, that means the admin has shut down the interface. Down and down, the interface has no shutdown command configured, but the physical layer has a problem. If it's administratively up, but still protocol down, almost always refers to a data link layer protocol. Normally that's caused when you have mismatched in layer 2 protocols. If it is line up, protocol up, everything is good. A router, when you're programming the interface, you have to go to our global config mode. Again, notice the config. Oh, that was kind of horrible. Then once you go to the interface, you'll notice the config if. To configure a IP address, the command is IP space address in dotted decimal form, the IPv4 IP, and then the subnet mask. You could also set bandwidth and clock rate. If we have a serial, we can do that by clock space rate, whatever clock rate we have, and bandwidth, whatever bandwidth we want. Normally you don't do serials though, so our Ethernet is the most common. Serial is very common in training, but not in real-world application. Router auxiliary could be if we have an aux port or some type of plain old telephone system where we want to connect to our auxiliary port, just in case of a backup. Again, very big early 90s, not so much anymore. Okay, the initial configuration, the setup mode. I'm sorry, I disagree with this slide. You never want the system to do this for you. You want to do this for you. You want to get used to doing this. You want to get used to the command line. Do not let the initial configuration or the so-called setup mode run. You want to know, you want to do this via the command line. You, the network admin. That way, you know exactly what's turned on and what's turned off. So upgrading the Cisco's iOS software and the boot process. You can actually do this by downloading the appropriate software from Cisco's website, whatever you bought. You get it to a TFTP server, and then you can copy the file from the TFTP with the copy TFTP flash with the appropriate command. Here we go. We get a copy of the TFTP in the flash. And it will actually ask you what the file name is, what is the address, and here we're going to be copying that file from that TFTP server. It will download, then install. Next, how do we actually start our router? This is the important one. First, post. Has to go through a power on self-test. Next, it will be loaded from ROM, but it'll load the bootstrap into memory. Then, step 3, it will load the Cisco's iOS from different areas, depending. It could be from Flash, from TFTP, from ROM. It could be different areas. Step 4, it will load the startup config and place that into a running config. And that will be brought by NVRAM, TFTP, or via the console. But that is our generic boot sequence. You have to know the order. Post, bootstrap, Cisco iOS, then the startup config. So the choice for choosing the OS at boot time, because sometimes modern Cisco routers may have more than one operating system, you could select the appropriate operating system. Here we have a boot option 0 and boot option 1, and underneath boot option 1, we may have multiple iOS files. So sample boot system commands could be boot system flash, the file name, or boot system TFTP file name and the IP address. And that's the bare bone basic router. If you have any questions, please let me know.